Good morning, friends. Welcome to another session. Today we are going to take the NEET test 56 released by the NTA, and I've just solved this paper. And from the paper, I can say only one question was tough for you because you don't study that dispersive power of prism, and plus I still feel the answer given is not right. I'm not agreeing with the answer. Similarly, in 24th, I'm not agreeing with the answer. 38 question has some issues. So all in all, it was not very tough. There are some good questions, but there are not very tough questions, I can say. So I have classified 20 as easy, 24 as medium, 1 as tough. So I feel you should score good marks in it. So an average student aspiring to get an MBBS seat should get 140 in this paper, and for good students you can make out 160, 170 plus should be the scores here, because all the questions are exactly the similar to what you study, plus many questions are repeated in these NTA tests. So now what I feel is they are also getting fed up because making 56 tests, each having 45 questions, now they are also like finding it difficult to come out with new questions. So you will see many questions that I've already solved in the previous test I have to solve yet again, but let's start what is in the paper. Hello friends, let's start the paper. Let's see what's the first question is. A circular coil of radius 4 centimeter having 50 turns carries a current of 2 ampere. It is placed in a uniform magnetic field of intensity 0.1 Weber per meter square. The work done to rotate the coil from equilibrium position by 180. So this is a standard question. You know that work external would be equal to, by 180 means that is from u unstable, u final minus u initial. Final is the unstable equilibrium. The energy is minus mb or mu b plus mb or mu b, and initial was minus mu b. So it comes out as 2 mu b. So that is 2 mu. Mu you know is NIA, that is 50 into 2 into A, which is pi into r square. 4 means 16 into 10 to the power minus 4 because it is centimeter into 0.1. So what we get now, this 0.1 and this get cancelled. 16 to the 32, 64, 64 320, 320 pi into 10 to the power minus 4, which comes out as, if I do this is 0.32 into 0.314 sort of thing. So it's roughly going to be 0.1 joule. I can directly make it out. So option A is the correct one. So next move on. Question number 2. A wire of resistance 0.5 ohm per meter is bent into a circle of radius 1 meter, and the same wire is connected across diameter AB as shown in figure. The equivalent resistances. So here if I see, this would be one resistance which is pi r. Pi r means this is pi into 1 and 0.5, so that is pi by 2 ohms. This would be pi by 2 ohms, and this would be 2r. 2r means this is 1 ohm, and this one all are across A and B, so they will be in what I say parallel. So R equivalent is 1 upon R equivalent would be, this is 2 by pi plus 2 by pi plus 1 by 1. So if I take the LCM as pi, this comes out as 4 pi pi. So R equivalent comes out as pi upon pi plus 4 ohms. So go for option C. So it's not tough if you can visualize it. So it's option C. Next, move on. Potentiometer experiment. If the voltage across resistance R and R plus R, okay, are balanced at L1 and L2 respectively, the value of resistance R is. So I can directly make out, because it will be, I am assuming the current will be same, there nothing else, so voltage ratios will be L1 by L2. So what I can have, R times L2 is R times L1 plus small r times L1. So small r is R times L2 minus L1 upon L1. That is what I can write. So looking at the options, it comes out as option C. Now, a 100 volt AC source of frequency 500 Hz is connected to LCR circuit. L is given, C is given, R is given, all connected in series as shown in figure. What is the quality factor? So now what is the quality factor? If you remember the direct results, I can write quality factor as 1 by R root of L by C, if you remember that. So substitute the values. R is 10, L is what? 8.1 into 10 to the power minus 3, and C is 12.5 micro. Micro means 10 to the power minus 6. So what we have now, this is 8.1, that would be 1000, and that would be 12.5. So I do this is 2500, so 80 into 8.1 I'm roughly getting. So roughly if I do this, this is 8 and 8 will get come out. So it would be 8 pi by 10 approximately, because root 10 is very much close to that mark of what we call as root 10. So looking at the options, because they are quite far, I can try my luck. 8 pi by 10, and pi is 3.14. 3.14 means it is 24 or 25 something by 10, so it is 2.54 would be the closest one I can go for. Now going ahead, plot the variation of EMF across the inductor with respect to time. So what happens across the inductor? Initially, inductor doesn't allow any current to flow, so complete drop will be there, and virtually it will become a wire. So it should decrease exponentially. We know that formula. We know I is equal to I naught e to the power minus TR by L. So VR I can find out it would be like this. So VL would be E minus VR. So it would be exponentially decreasing curve. So it is going to be C. Next one. A charged particle q1 is at a position 2 comma minus 1 comma 3, okay, 3D coordinates. The electrostatic force on another particle at q2 at 0 comma 0 comma 0. Now, so the electrostatic force on another charged particle q2 is, so I can directly say the force would be, as per I know, k q1 q2 by r square, and to be precise I should write it as r of 2 with respect to 1 cap. This is what you write. R square also means r21 square, so I just simply wrote it like this. So first of all, what is this r21? So r21 would be minus 2i cap plus j cap plus 3k cap. So what I can write it as r21 by r21 cube. So if I take this magnitude of r21 comes out as 4 plus 1 plus 9. This comes out as root 14. So what I can write, k is 9, okay, k 1 upon 4 pi epsilon naught, q1 q2, r cube I should write as 14 root 14, and I should write it as minus 2i plus j plus, sorry, not plus, it should be minus, otherwise I would be not getting any answer, minus 3. So this is minus 3k cap. Okay, so first looking at the options, there is only one. You can directly make out from the direction vectors only, and if 14 4s are 56 root 14, so option D is the most appropriate. So simply checking, you know, Coulomb's law in vector form or not. Next one. Three charges q minus q minus q plus q minus q are placed at equal distance on a straight line. If the potential energy of the system of the three charges is 0, then the ratio of, okay, so you have placed it like this, minus q, q, and minus q. Equal distances means, let's say, a and a. So what I say, the u of system is, first of all, for these two, minus kq by a. For these two, this is again double. Now for this one, now for these two, I can write it as plus kq square, and the gap is a plus a, that is 2a equals to 0. So simplifying this, what I get 4q is equal to capital Q. So capital Q by small q is going to be 1:4. Okay, next one. A square loop of side A is placed at a distance a length away from a long wire carrying a current I1. If the loop carries a current I2 as shown in figure, the nature of force and the amount is. First of all, look at this. This nearer side has the same current, so this would be attractive, this would be repulsive, net force is going to be attractive. So I have to go for these two options. Now, going by the expression of force, first of all, this attractive force, let's call it F1. So F1 would be mu naught I1 I2 upon 2 pi d. D means a into length a. Okay, so we will get a option not as a inside, dimensionally it is wrong, so it will be directly this. I can also solve it like this. F2 would be repulsive, this would be mu naught I1 I2. The gap will now become a and a, this will become 2a into a. So you can solve it, subtract it, you will get the same value. Okay, next one. Charged particle of mass this comes out of accelerated tube with kinetic energy. Calculate the smallest magnitude of the magnetic field that should be applied in vertically downwards direction to just prevent the charged particle from colliding the plate. Okay, so just preventing it from colliding the plate means it should go like this, like this. So in limiting case, the radius would be 10 to the power minus 2 meters. And we know radius is root 2 mk by qb. So I can write it as the b is root 2 mk by r. So just put it rq, sorry. So root 2 m is what? 1.6 into 10 to the power minus 26. K is 2 into 10 to the power 3 ev. So converted into SI unit, 10 to the power minus 19 upon r is 10 to the power minus 2. Q is 1.6 into 10 to the power minus 19. So this 1.6 will get cancelled. This is 26, 23 and 19, 42. And this is 21, so 10 to the power 21 also get cancelled, 2 2s are 4, so this is simply comes out as 2 Tesla. So go for option A. So calculation appeared difficult, but it turned out to be quite easy. Next one. Slab of two parallel layers of copper and brass are given. Okay, so we have these two layers, and same thickness having thermal conductivity in the ratio 1:4. Okay, so if I this is copper, this is brass, this is given K, this is given as 4K, so I can conversely say if this is R, this is 4R. Okay, free phase of brass is at 100 and this is at 0. So because it is 4R, it is R, I will say the drop of temperature will be in the ratio 1:4, so total will be 5 times. So 1:4, if I divide, this drop would be 20 degrees Celsius and this drop would be 80 degrees Celsius. So the junction temperature comes out to be 80 degrees Celsius. Go for option A. Next one. System is taken through a cyclic process represented by the cycle, the heat absorbed by, and definitely it should be meaning net heat absorbed. And here if I do this, this would be the area under the curve and I treat it as ellipse. So the area is ellipse pi AB. So A is what? This is 50, I suppose. Yes, 50 into 10 to the power 3, and this one is what? 10. So 10 into 10 to the power minus 6. Okay, that is what I am getting. So 1 2 3 4 5, that is 0.5 pi. I am getting 0.5 pi means pi by 2 joules. I should go for option B for sure. Next, the cyclic process shown in on the VT diagram, the same process on a PT diagram is okay. So we are given the diagram on the VT and we have to find the diagram on the PT. So first of all, A to B, VT straight line through origin clearly suggests P is constant. Here also P is constant and in the rest of the two temperature is constant. Okay, so it would be like a parallelogram or a rectangle, you can say. Now in A to B, pressure is constant and volume and temperature both are increasing. So A to B, volume, temperature increasing. It's okay here. It's not okay here. It's not okay here. And it's not okay here. So it's only one option I am left by looking at A to B. So clearly I'll be going with option A. No other choices to look at. Next one. In an adiabatic expansion of air, the volume increased by 5%. What is the percentage change in pressure? So in an adiabatic expansion of air, it is also given treated as diatom. Really sorry, I solved 4-5 questions more and somehow that my headset battery got discharged and I came to know that the recording hasn't happened. So let's say now I don't want to solve it again, so I'm just telling you here, because the volume increases by 5%, it is adiabatic expansion. We know PV to the power gamma is constant. So because PV to the power gamma is constant, I applied P initial, V initial to the power gamma is P final, V final to the power gamma. So the final pressure would be, final volume would be 1.05 V naught. So final pressure would be like this, and this value is given. This will come out as 1.07, and because it is not a very big change, you can directly go for 1 upon 1 plus x can be written as 1 minus x. So it would be 0.93 P naught. That means 7% decrement. Similarly for the 14th one, I am again reading it for you. Iron tire of diameter 2 meter fitted on a wooden wheel of diameter this, temperature to which should be heated. So basically you have to heat it so that 2 becomes 2.01. This is the equation you will get. So what we have, 2 alpha delta T is 0.01. Substituting the value, I just made it out that this would be a 450 plus. So 450 plus 20, it would be 470 plus something. So for as the available option, it is 474.5. So you can look at what I have done. Similarly, this is important, I'll tell you. 50 gram of ice was at 0 degree, 50 gram of water at 80 degree. So what you had, 50 gram water at 80 degree and 50 gram ice at 0 degree. So you know, for ice to melt to 0 degree, it is to become 50 gram water, it requires 50 into 80. And just 50 into 80 should strike. If it comes to 0 degree, remains water, it would be released 50 into 1 into 80. So both are equal, that means it is the exact the same amount. So finally you will have 100 gram water at 0 degree Celsius. Next one, there is a string mass given, tension given, the length of the string is given, a jerk is stuck at one end of the string. How long does the disturbance take to reach the other end? So it's simply, first of all, tension, length and mass is given, so you will calculate velocity root T by mu. I calculated, it came out as 40, and the time taken would be to go from one end to another. Distance is 20, speed is 40, so it would be 0.5 seconds. Now choose the wrong statement. 0 velocity at any instant necessarily means acceleration 0. No, a0 doesn't implies v0, v0 doesn't implies a0, so a and b both will be false. If the speed of the particle is constant, the acceleration must be 0. This is wrong. You know, in uniform circular motion, speed is constant but still acceleration is non-zero. It is needed to change the direction. And the same question came again, what happens in a uniform circular motion? Velocity and acceleration, both's magnitude remains constant but their direction changes continuously. So vectorially v and a both are not constant, both are changing. Now the 19th one, this one I am doing now when I realized that there is some issue that is arrived. Okay, so let me do it again. A block A kept on an inclined surface just begins to slide if the inclination is 30 degrees. Now, so what we have, inclined plane just begins to slide if inclination is 30, so that means tan 30 is mu s, so mu s is 1 by root 3. Now the block is replaced by another block B, and it is now found that it slides if inclination is 40. Typically, if the block is of same smoothness, it would be 30 degrees because angle of repose depends on mu, so angle won't change because by the mass. Here the angle has changed because it might be more smoother or more rougher, sorry, so we cannot make out from mass. I can simply say the contact surfaces are not exactly the same, so all three options are possible. I cannot comment whether the block mass is less or greater or equal because mu this thing doesn't depend on it. If the surfaces are the same, it doesn't matter if it is a 2 kg block or a 10 kg block, the sliding angle, the repose angle will be the same. Now, so it's a good conceptual one. Elastic ball is dropped from a height 100 meter. If due to impact it loses 35% of the energy the ball will rise to. You can directly look at the topmost point. The topmost point U is mgh, so that has decreased by 35%, so height also decreases by 35%, so it is 65 meter. Again similar, more tougher question have come before, so it's an easy one for you. Go ahead. 21st, three particles with masses 10 and 30 are at this center of mass. So again there's many question I can see from CM theory here. So 10I plus j plus k m1 r1 plus m2 r2, that is 30 into minus I minus j minus k over the mass 10 plus 30 40. So I get what? Minus 20 I plus j plus k by 40. So now you can make it out. It's option A I'm looking, that is going to be the correct one. Next one. Object of mass 5 kg, speed 10, explodes into two pieces of equal mass. One piece comes to rest. The kinetic energy added to the system during the collision is. So from momentum conservation I can say it should be conserved to 5 into 10. 1 comes to 0. So plus 2.5 into V. So V comes out as 50 upon 2.5, or you can say 20 meter per second. So the kinetic energy added, K final is half into 2.5 into 20 square. 20 square is 400. 200 into 2.5, that is 500 joule. Initial kinetic energy is half into 5 into 10 square, so that is 100. 500 by 2, 250 joule. So the addition I can make it of 250 joule energy is added, basically doubled. Kinetic energy is doubled. Particle strikes elastically with another particle with velocity v. After collision it moves with half the velocity in the same direction. Find the velocity of the second particle if it is initially at rest. So I think this is again a repeated one, the same question as we have done before. Let's do it again. Another particle, so let's say first one is m1u, which was at rest, so it was 0, that would be equal to m1 in the same direction with the half, that is u by 2 plus m2v. And from velocity of approach equals velocity of separation, what I get, u minus 0 would be equal to v minus u by 2, so v comes out as 3u by 2. So directly I can say, I need not to write the first equation, v would be equal to 3u by 2 or 3v by 2 as per the question, option A. Next one. Small sphere is given vertical velocity of magnitude 5 and swings in a vertical plane about the end of the massless string. If maximum tension string can withstand is equal to twice the weight, then the angle theta at which it breaks. Again, this is a question you must have found in your sheets. So let's say something. So let's see at an instant it comes at an like this, and this angle is theta. I draw the FBD. This would be mg. This would be tension. This is again theta. So what I write? T minus mg cos theta is mv square by r. And what is v square? From energy conservation you say 2gh, and h would be this thing r cos theta by r. So what we have, T comes out as 3mg cos theta, and as per the question 3mg cos theta. Okay, this 3mg cos theta, this would be, sorry, it is 2gr cos theta plus u square here because initial speed is also there, so that would have resulted into mistake, so correct it. I just sensed from the option that such option is not possible. Then I again looked at the mistake I have done. So now T is 2mg, so just substitute this value 2mg minus mg cos theta. That comes out as, I again write it as 2mg cos theta plus mu square by r. That is what I am writing now. So what I will get now, this r thing, okay, will sort it out what to do this with r. U cos theta plus u square, so going by it, what I get, let's say mm get cancelled first of all, so take it here there only. So what we get, 2g minus 3g cos theta u square is what we have 25 by r. Okay, so that we are getting this result, and the value of radius is given or not? It's not given. Let me do it. So what I have now, 20 minus 30 cos theta is equal to 25 by r. So there is something missing, and I feel this length is given, and this is I can remember this should be equals to 2 meter. Then also I can do this. So if it is 2, I will write it as 12.5, and then I can have 30 cos theta equals to 7.5. So cos theta equals to 1 by 4. So then it would be cos inverse 1 by 4. So question is incomplete. Without the value of r, you cannot solve this. Actually, this should be printed on the diagram in the original question, that I know. So there's a mistake in this question. You will definitely be left wondering what should be the value of r. Okay, go ahead. The height above surface of Earth where the value of gravitational acceleration is 1/4 of that at the surface. Okay, so it is becoming 1/4, a big change. So g to become g by 4. So what we say, g upon gs surface would is equal to r plus h upon r whole square. Okay, so simply this would be 1 by 4. Okay, reverse I have written, this is not the right way. G upon g at surface would be equal to r upon r plus h whole square. So what we have, 1 by 4 is equal to r upon r plus h whole square. So clearly r upon r plus h is equal to 1 by 2. So simply h is equal to r. So you know h is equal to r. So it's an easy one for you, not a tough one. You should have done such questions before also, I suppose. So this is h equals to r. Going ahead, go for 26 now. The orbital velocity of an artificial satellite in a circular orbit just above Earth's surface is v for satellite orbiting at half of the Earth's surface. So just above Earth's surface means v is equal to root gm by capital R. Now at half, that v dash will become root gm upon small r will become r plus r by 2. So that becomes root 2 gm by 3r. So I can take it as root 2 by 3 times v. So again, option C, definitely you can go for this. So not a tough one. Simply you need to know what is the orbital velocity. Next, for definite length of wire, if the weight used for applying tension is immersed in water, then then tension decreases because of the what we used to call it as buoyancy force. Tension decreases, speed decreases. So then definitely fundamental frequency or the frequency will also decrease for the wire. So it should become less. Next one. A simple pendulum 4 meter long swings with an amplitude 0.2. What is its acceleration at the end of its path? At the end of its path, you know, acceleration is only the what we say the tangential acceleration. That would be equal to what we write as g sine theta. So what is sine theta? It's amplitude of 0.2. So if I let me draw. So this is theta. So let's say I approximately take it to be 0.2 and take it to be let's say for this or this, nothing happens because the angle is very small. Sine theta is 10 theta. You can write it to be 0.2 by 4. So 10 into 0.2 by 4. So it comes out as half. Yes, it comes out as half. That is 0.5 meter per second square. Next one. The bulk modulus of water is 2 into 10 to the power 9. We know the change in pressure required to change the density. So you know delta rho by rho is equal to delta P by V. That you remember. So what is the change in pressure? The change in pressure is bulk modulus 2 into 10 to the power 9, and delta rho by rho is simply delta V by V. So to change it is 0.1. 0.1 means 0.1 by 100. So it is 10 to the power minus 3. So 2 into 10 to the power 6 Newton per meter square. That should be the option as per me. So option C is the right one. Next, go. Mosquitoes with 8 legs. This is a standard question. Stands on water, and each leg makes a depression of radius A. If the surface tension is T and 0 respectively, then the weight. So what we say, it is a radius A. So each will put a force T into 2 pi R, 2 pi A, and 8 times would be equal to mg. That would be supporting the weight. So this is definitely you have done in your surface tension. So the weight is going to be what you can make out 16 pi Ta. So easy one for you. 3 identical rods, each of mass m, length L, are joined to form an equilateral triangle. Okay, find the mi about the BC. Okay, so these are rods. So about BC, this mi is 0, and if I just remember about such an axis, you don't need to take this length, you need to take only this component of the length, which I can write as L sine 60. So it would be m L sine 60 whole square by 3 and multiplied by 2 for both. So simply I can write 2m by 3 L sine 60. L sine 60 is root 3 by L, so this becomes 3 by 4 L square. So what I get now as ml square by 2. So go for C. So you can derive the result also if you don't remember. That's not an issue. So you can do this. These questions are common. Big particle, mass 3 plus m, blast into 3 pieces. One has 1 long x, 2 meter per second, okay, speed. Particle of 2 moves with velocity 1 perpendicular to direction of 1, that is in y. The third particle moves with velocity then. So simply it's blast, so final momentum should be 0. So 1 into 2 I cap, let's write it like this, and 2 into 1 j cap, let's write it like this, and the m3 mass would be m. Okay, m plus 3 is the total. So m into root 2, whatever be the n cap direction you can write, would be equal to 0. So what we have, m root 2 n cap would be 2i cap plus 2j cap. So if I have to take the magnitude only, so m root 2 is equal to 2 root 2. So comparing it is 2 kg. There's no issue. The value of m comes out to be 2 kg. An alpha particle of energy 5 MeV is scattered through 180 degree by a stationary uranium nucleus. The distance of closest approach. So this is a head-on approach. So distance of closest approach, you know, k q1 q2 by r minimum would be equal to k of alpha. And q1 q2, you know, the values are there. So what is r minimum here? It is 9 into 10 to the power 9. q1 q2, alpha is 2e, and uranium you know is 92e. I am writing e for a reason. 5 MeV, that is 1.6 into 10 to the power minus 19 into 10 to the power 6, you can say, and this get cancelled because I am converted into the EV, mega EV to joules in the SI unit. So what we have now, so 19 and 6, 25 and 9, that is 10 to the power minus 16. This comes out as 92 into 9 into 3.2 by 5. So definitely if I look it around, it would be 100 to 10 to the power minus 14 meter. That is roughly I am getting. So 10 to the power minus 12 centimeter would be the closest distance of approach. I can make it out from here. Next one. A hydrogen atom in ground state absorbs this energy. So it will go, you know, this energy will take it from 1 to 2. The orbital angular momentum, you know, is equal to nh by 2 pi. So it is nh by 2 pi. So 2h by 2 pi minus h by 2 pi. So the delta L would be h by 2 pi. So 6.63 into 10 to the power minus 34 upon, you can write it as 6.28. So it is 1 point something into 10 to the power minus 34. Go for option A. So again an easy one, not a tough one if you are thorough. The activity of a radioactive element decreases to 1/3 of the original activity in a period of 9 years. Okay, after a further lapse of 9 years. So just remember this thing. I tell my students time and again, if it is n naught, if after any t naught times it becomes n naught by x, so after any 2 t naught time it will become n naught by x square. After 3 t naught time it will become n naught by x cube. This magic of half square, half cube doesn't work for half life, it works for any period. So if in 9 years it becomes 1/3, so in another 9 years it will become 1 by 3 square. That is what we can say, 1 by 3 square, that is 1 by 9. Go for option C. You can do from the exponential logic. The exponential logic is simply e to the power minus 2x is e to the power minus x whole square, nothing else. 36. In the photoelectric effect, the slope of a straight line graph between stopping potential and frequency gives. So we know what it is. We know just the basic equation, k max is ev naught is equal to h nu minus phi. So v naught is h by e nu minus phi by e. So you know this is ratio of Planck constant to the charge on the electron. This is d1. A photocell is illuminated by a small bright source placed 1 meter away when the same source is placed half meter away. This is the same question we done probably in JEE mains or something. Because it is placed half meter, distance is half, intensity is 4 times, so the factor will increase by a factor of 4 because more photons strike, so more electrons are expected to be taken out. A plus b ka bar plus a bar dot b ka whole bar is equivalent to, again if you know the De Morgan theorem, you could go for it. Again this is the same question I am getting repeated. If you look, this A and C are exactly same, so no point in asking this question. This is definitely equivalent to, but it definitely would be looking for something else. So one is De Morgan theorem, which I generally don't want you to remember. I generally don't say my students to remember, though I will take this in this physics revision series, but I'll simply go by my standard way of 0 0 0 something, take both as 0. What I will get here, so 0 dot, this would be 0, this would be 0, because 0 0 that would be 1, so 0 0 should yield me 1. So if I put it here 0 0 yielding 1, it would be 0. So it is, because 0 dot 1 is 0 plus 0, this is not going to be right. This is already rejected. This is 0 plus 0, this is 0 dot 1, so this is also 0, so this is also rejected. Only a option is there. Let me check again also. This is 0 plus 1 plus 1 plus 0, so it is 1. So by just checking 1, I can make it out. This should be option B, and C is automatically a choice. In a transistor, the base is made very thin and lightly doped with an impurity because we want that base current to be as low as possible, and want the electrons from emitter to go directly to the collector. So this is option C. That is the most appropriate that I can think of. Next one. The current gain for the transistor in CE mode is 98. Low resistance is voltage gain. So simply AV is resistance gain into current gain. Current gain is 98. Resistance gain is 110 to the power 6 upon 600. So do this. So what I get, 6 table, that is 1 and sorry, not it comes in 6 table. Okay, but 49 by 300, let's say. So what we have now, 49 by 3, if I do, this is 49 by 3. Nowhere this figure is going to come. It is huge. I don't know how much it is super, what we can say, gain I'm expecting here. So voltage gain would be huge, so it's not going to be any one of them. I still don't remember what it is they are writing. If the load resistance be 1 ohm and the internal resistance be 600 ohm, what is the voltage gain? For me, the voltage gain is like this, is definitely very large as per the options. The solution they have given also, I don't see. So I agree with the answer, but not the way the NTA has solved it. Okay, so go ahead. 41st. The dispersive power, again the dispersive power questions are coming. Students are regularly asking, so please study it. Are 0.05, 3.04, and the mean refractive indexes are this for white light. Calculate the angle of the flint glass film required to convert an achromatic combination. Achromatic means you didn't need any dispersion then. So what we need to have then, now dispersive power, first of all, omega is that what we say, the dispersion that is generally caused, that is mu v minus mu r upon a upon mean deviation, which you write as mu of a mean, or a mean I can directly write minus 1 into a. So for this I can say this mu v minus mu r into a, and no need to cancel this a. So mu v minus mu r into a is equal to omega times mu mean minus 1 into a. So for no dispersion, what we need, omega 1 into mu v 1 minus 1 into a1 should be equal to omega 2 into mu m2 minus 1 into a2. Okay, so you have to find the angle of the flint glass. So first let's say flint 1 is 0.053 into 1.68 minus 1, that is 0.68 into a1. I need to calculate. This is 0.034 into this comes out to be 0.53, this comes out to be 4. So this a1 comes out as 34 by 53 into 53 by 68. So data is very simple. So what I get, this is 2, this is this comes out as 2 degree. So if you are thorough with this concept, generally people don't remember such things, but if you remember, you can. So as per me, the answer should be 2 degree. They have given 5. I don't agree. Might be I went wrong, but what I can see, I can feel it should be 2 degree. Yeah. Next, 42. An equilateral prism deviates a ray through 45 degree for 2 angles of incidence differing by 20 degree. Okay, the angles of incidence are, so first of all, I can, if I draw this del versus I, it was something like this. This is the sort of curve you generally draw, and let me draw it again. This is typically you draw it. Okay, so the angle of incidences differ by 20 degree, like this. So what I can say, if this is I1, this is I2, I know for this I1 this would be E1, for this I2 this would be E2. So what I can say simply, deviation is I plus E minus A. So what I can write, 45 degree is equal to I, let's say light is I1, plus I can write it as I2, minus I can write it as A is 60. So I1 plus I2 comes out as 105, and as per the question, this I2 minus I1 is 20. So try adding it. 2I2 is 125, so the angle is 62.5, and then corresponding would be 42.5. So it is C option. Next one. A narrow slit of width 1 mm is illuminated by monochromatic light of this wavelength. The distance between the first minima on either side. So first minima comes out as, okay, what we have, it is a diffraction. Okay, the first minima comes out as 1.5 lambda L by A. So because on both sides it should be doubled, so it should be not 1.5, sorry, it is the maxima, so lambda L by A, so it would be 2 lambda L by A. That is the width of the central maxima. I can directly write lambda is 600 and this length is 2 and this is 10 to the power minus 3. I think this question has also arrived before. So 4 6 are 24 into 10 to the power 5, 10 to the power minus 4. So this is 2.4 mm. You can go for option D. I just remember this has already come in some NTA test before. Next one. So I think they are also repeating questions too much now. Unpolarized light at intensity passes through three polarizers such that the transmission axis of the first and second makes an angle 30 with each other, and of the last polarizer is crossed with that of the first. That means theta 1 is 30 and the next one will be 60 degree. You can directly make out because this is the first one, this is the second one, this is the third one. This is 30, that was crossed, that is 60. So what I will have after first, intensity will become I naught by 2. After second it will cos square 30, that is 3 by 4, and cos square 60, that would be 1 by 4. So 4 4 16 32, that is 3 I naught by 32. So this simply comes out to be 3 watt per meter square. So again you can do this. This is not a tough one if you can read it easily. Next one. Two thin uniform rings made of the same material radii r are 4 are joined as shown. The mass of the smaller is small m. Okay, same material, and if you have this is the same thing, this is m, this is going to be 4m. Of the system about an axis passing through the CM of the bigger rod and perpendicular. So about this it would be 4m into 4r whole square, and this would be about its own axis is mr square, plus if I have to shift it by 5r. So what you have, 16 4s are 64 mr square. This is 25 26 mr square. 64 and 26, what we get now, 1790 mr square. So go for option B. That should be my answer. Next. So this was the question number 45th. So as I told you, I will be doing some questions from chemistry which I can feel are part of physics. So first one, calculate the wavelength of the radiation emitted when a hydrogen atom falls from infinity to stationary state 1. So that is infinity to 1. So I can directly write 1 upon lambda is r, 1 upon 1 square minus 1 upon infinity square. So lambda comes out as 1 by r. 1 by r means 1 upon 1.097, and if I take it above, it is 10 to the power minus 7. I can write it as 100 into 10 to the power minus 7 into 1.097 into 10 to the power minus 9, sorry. So this is in nanometer, so it would be some 90 something nanometer, 91 nanometer I remember. So 91 nanometer is what the answer is. You must be remembering this value, most of you must be. So next question number 18. 231 actinium, maybe AC is actinium, some alpha and beta comes into lead, the number of alpha and beta. So I just told you yesterday also, this is 231 to 207, the change is of 24, each alpha changes by 4, mass number changes only by alpha, so 25 by 4 is 6 alpha. So alpha is 6, and this leaves you with one option, but let me solve it again. 6 means there's a drop of 12, but here the drop is only of 7, that means there's a difference of 5, so 5 beta negative particles will be there. So 6 and 5 you can do. So that was the today's paper. So from physics I have solved not 45, I have solved 47 questions. Keep watching, keep sharing. Please share this channel. Still I feel the reach of the channel should be much more. The effort I am putting in and looking at there are actually virtually no one solving these papers on the daily basis as I am doing. So please refer to this to your friends, as many friends you can. They will definitely benefit. Thanks for watching.